Our next speaker used to fence for years, even at the collegiate level. So please welcome our fencer, Rachael.
All right, welcome. Emphasis on used to. Please don't come at me with a sword. Hi, I'm Dr. Rachael Tatman. The doctorate is in linguistics, which is why I have so many opinions on language data. And I am a senior developer advocate for Raza. We build software to help people build chatbots. I'm not going to be talking a whole bunch about chatbots today, but I am going to be talking about mistakes you'll probably make with language data, that I've definitely made with language data, and how to recover. So, little sneak preview. Here's all the mistakes. We're going to go over them in depth. The first one is that transcribed speech is not the same as text data. So this one is, particularly relevant for me in my work with chatbots, where often people will train a chatbot with some sort of text-based model, like somebody texting, and then they'll want to add a voice component, and they'll try to use the same model for both and have a bad time. And there are lots of reasons for this. I've picked up a couple just like specific points that you'll probably run into. So one is that people do not speak in full sentences. A lot of the parsers that we use, so to take text input and create or perform a structure upon it, to put it in sort of a weird way, are based on the idea that you're going to have text data that is formatted like Wall Street Journal text data, and people do not speak as if they were writing for the Wall Street Journal. Also, punctuation is going to depend on your specific automatic speech recognition platform, what you're using to take the speech input and turn it into text. Speech includes disfluency, so things like and etc. And these are natural. Everyone has them. You have them, even if you think that you don't. And they also contain information about how the speaker's feeling, how certain they are. There's a lot of rich information in disfluencies that are not available in text and will, if you are not expecting them and they appear, cause you some headaches. And sorry, I'm having trouble clicking just once. Another big thing that's different between speech and text is token frequency. So tokens are words, usually in English. We'll talk a little bit about that a little bit later. And a lot of the methods of analysis of text data are counting tokens. And the counts are often very different between speech and text, even on the same topics. So I have here some data from Swedish, actually, and you can see the most common tokens, again, in Swedish, in speech and also in writing, and then the frequency. And they sort of demonstrate some general patterns of differences between text and speech. So speech tends to have more pronouns, I, me, we, you, us. Those are the English examples. And also a more skewed frequency. So people will say frequent things more frequently in speech than they will in text. And also text tends to have more rare words. So there's a pretty big difference in the distribution of tokens between speech and text. And that means that you don't want to just take a speech model and use it for text data without retraining it, and vice versa. Even if you have a model that works on some sort of written input, just because you've transcribed speech does not mean that it will continue to work equally well. And the big fallout of this is that you're going to want to budget more time for multimodal work, either for developing completely new models or for recalibrating the ones that you have, whatever those models might be. So that's number one. Number two, underestimating the amount of variation in language. And the specific two types of variation that people run into most frequently are social variation. So who is saying or writing this language data that you're working with, who's produced it, and then genre and register. So how are they communicating? I'm going to talk more about both of these. What is the tone? How professional or formal is it? What is the topic that they are talking or writing about? So for example, a bank means something different in a velodrome, little bike racing rack on the side, a little bike racing track than it does in finance or watershed studies. The same word will have different senses. And the number one takeaway from this portion is that models trained on one variety don't often transfer easily. So very quick introduction to sociolinguistic variation. This is linguistic variation that is a reflection of social identity. It exists at every level of the grammar. So a common misconception is that accents are something that only happen in speech, and that reflection of someone's social identity isn't reflected in writing. Very much not the case. So a couple examples, a caught merger, which I imagine most of y'all in New York don't actually have, but people out here in the West, where I am currently, do. Whether or not you have a nose in your emoticons, so this is actually an age marker. There was a change where people went from using noses to not using noses, and generally older speakers will use noses. Lexical variation, do you call something a firefly or a lightning bug? Syntactic variation, so can you say something like, the car needs washed, or we stay at home anymore? And do both of those things make you go like, ooh, that sounds weird. I wouldn't say it that way. And then semantic variation. So the same word having different meanings, like lift, to carry, or the elevator equivalent in the UK. Torch, is it on fire or not? Boot of a car, boot that you put your foot in. And here I realize this is red-green, but that's the color that the graphic was made in, is a distribution of second person plural. So you guys in the West and the North, y'all in the South, and then a bunch of other variants like yins that aren't on there. So that's social variation, genre, and register. So these are, again, if you're trained a model on one population, there is no good guarantee that it's going to work on a different population. And specific genres or registers, the terms are kind of interchangeable, that you might run into include noisy user-generated text. That's the technical name. This is things like Twitter, Reddit, Facebook posts, etc. Phone calls or conversations. Telephony, the study of using telephones, is a very distinct subgenre of the ways that people use language. Reviews, a specific genre, Yelp, Amazon, etc. The Wall Street Journal in particular, I've already mentioned it. It was a very popular corpus. It informed a lot of early NLP work. And the specific one that you're trying to analyze or use for your specific project, which may or may not overlap with some of these other genres. And these are just sort of a sampling to get you thinking about what sort of types of language use your data falls into. So this is kind of an easy one. Kind of. Just know that language varies and that it will show up in your data. If you are building something that's going to be used by a wide variety of people, I recommend socially stratified validation to make sure that it works across groups. So if you know, for example, that people from New York and Atlanta are both going to use your product, maybe test it with people from both New York and Atlanta because they're going to use language in different ways. And, as in with all statistics, find data as close to your target as possible, whether that's in who's saying it or what they're talking about. All right, third, overdoing the text cleaning. This is a great one because my takeaway from this is going to be that you should do less work. And the expression that I think about here a lot is throwing the baby out with the bathwater, which means getting rid of something you don't want and also inadvertently removing something you do want. So just a couple examples here where text cleaning would remove important information. This top one, cheesecake, heart eyes emoji, cheesecake, vomit emoji. In one of these, someone is really excited about the cheesecake, and in the other one, someone is really not excited about the cheesecake. Maybe they're lactose intolerant. If you remove special characters, you will lose that information, which may be very important to your project. Also changing the case of things or mapping things that have, duplication or spelling differences in them may also result in losing information. So I love cheesecake versus I love cheesecake, all uppercase, exclamation point. That person is probably a lot more excited about cheesecake than the first one. Also, you may not need to remove stop words. So this is very common. Stop words are very frequent, but not very informative words. And I'll show you an example in just a second. If you are not using a frequency-based technique, like TF-IDF, the Fs there are frequency, the word frequency, where having something very common is going to skew your measurements, you should just keep them in. You don't need to remove them. So pre-trained language models, that's what LM is, like BERT or GPT-2 or 3 or T5 that you might have run into, these do not remove stop words. So if you're using anything with language models, keep them in. And just to show you the type of information that you lose from removing stop words, I've removed the stop words here. So keep stop words using frequency-based technique. That has inverted the meaning of the first sentence. Pre-trained LMs remove stop words using need keep. Right? So I just removed all the stop words in the NLTK's English stop word list. It's a Python framework. It's not as popular these days as it once was. It was just a benchmark to use to show you stop words tell you things. They are important. And if you don't have to remove them, don't remove them. So again, this one's kind of a nice one. Don't do as much text cleaning. Only do the amount of text cleaning that you absolutely need to do for the specific method that you're using, and it's going to depend on your method. And as always, work on a copy of the data. Make sure that you're not removing information permanently. I think that's just hopefully something that everyone already has in their heart, just like tattooed on there. All right, number 4. Only looking at the text. So as with other types of data, metadata can be very informative when you're looking at text data. But if you get really deep in NLP methods, sometimes it can be easy to forget about it. So who is saying and writing this? I already mentioned sociolinguistic variation. Someone's social identity is going to have a big effect on the type of language that they produce. And is this maybe, say, the same customer? It's been like the last 9 times in a row. There might be very important information in the fact that this person is, repeatedly interacting with your system. When did they say or write it? So there's one thing that you can guarantee when it comes to studying language, and that it will change, and it will change constantly and consistently. And also, the world and the things that we talk about change. So for example, there might be a worldwide event that everyone is suddenly talking about that they weren't 3 years ago, that has changed patterns of language use and that your project needs to account for. Where or how did they say it or write it? So on what platform? I write differently on Twitter than I do in emails, for example. That's going to affect the text that's produced. Is that genre? Yeah, it's genre. And why did they say or write it? So particularly if you are doing task-oriented systems like a chatbot, I'm thinking about chatbots a lot these days, that's very important. That's information that you're going to want to figure out if you can access and use. So just make sure you look at the metadata. Don't forget about it. Don't go so far down the text-based rabbit hole that you forget about the other types of information at your disposal. And finally, Anglo-centrism. So this means centering, in this particular instance, the English language. And I would say that this is a field-wide problem in natural language processing. The field as a whole has been very focused on English since basically its inception. And with that comes a lot of assumptions built into tooling and trainings that you might have had that don't hold very well. So for example, not all languages are written or spoken. So many languages don't have writing systems or have writing systems that aren't accessible in Unicode. Not all languages are spoken. Signed languages are an important group of languages that are many people's primary mode of communication. Not all languages have big training corpora available. More and more of them do, and that's fantastic. But even something like French is not going to have nearly the order of magnitude of training data that English does. English is very, very data rich. Most other languages just aren't. Not all languages use white space. A lot of tools will be built around the idea that there will be white space in the text, and that does not hold cross-linguistically. So a lot of East Asian languages in particular just don't use white space. A lot of languages don't use words as the smallest unit of meaning. So English is very grammatically impoverished. We don't have a lot of morphological complexity. And this is sort of on a global scale. I would say English is pretty extreme in this regard. It's very similar to Mandarin in that way. Whereas something like German that you might have run across, or Athabascan languages of the Pacific Northwest, for example, have a lot of morphological complexity. So a single word may be extremely long and have a lot of smaller grammatical units in it. So treating the word as a unit of meaning doesn't really hold very well cross-linguistically. Not all languages have canonical spellings or stable spelling systems. This implies that you're using a character-based or like a phoneme-based writing system, which I would hope that most people have encountered or at least sort of know about non-phoneme-based writing systems. For example, Chinese, Mandarin, or traditional or simplified characters are a great example of a non-phonetic writing system. And many languages are used intermingled with each other. So it is honestly, like, again, globally, a little weird that a lot of English speakers just speak English and, like, in the same sentence, it's all English. Many global language communities will, are very multilingual and will use a lot of different words in together. Even in the United States, Spanish and English together is very, very common. So a lot of assumptions, a lot of tools are built around these assumptions, and they just aren't true. But I'm not just gonna be like, know about all languages. I'm going to give you some orgs and resources to kickstart the work that you might be doing for non-English stuff. Also, these slides are available on my website, so don't feel like you have to type all these URLs now really quickly. Rascahane is a grassroots NLP community run by African NLP researchers. They've done work on, not every language in Africa. It's a very, very linguistically diverse place, but a lot of different African languages, and they are actively working on developing tools for African languages. So it's a great group to follow if you're working with any of those. If you're working with Spanish, which I'm guessing is going to be a little bit more relevant for this group, Hugging Face, which is a NLP startup that's does a lot with machine learning models, has a community specifically for Spanish and a lot of resources that they've developed. That's NLP NES, ISO code for Spanish. And then the, I'm not sorry, I don't speak Spanish and I don't really want to say this bad, but the University of the Republic in Uruguay has a fantastic NLP group that has made a lot of Spanish language resources available on their GitHub, and I definitely recommend checking that out. Some of them are in Python, but some of them are just sort of programming language agnostic, and you'll be able to use in your own pipelines. And my big tip is, if you are interested in a specific language that's not, spoken in Africa or Spanish, which are what these resources are for, I would go to the ACL Anthology, which is the collection of all the peer-reviewed published papers that the ACL has published. The ACL is the big research conferences for NLP, and a great repository of knowledge. And I would search for your target language there, see who's working on it, see what they're working on, see if there's any open source tools. The NLP research community is pretty good about open sourcing stuff. And start your search there. So things to think about. Most people don't use English cross-linguistically in the world, so just keep that in mind. If you are working with a target language that you don't speak, so for me, again, that would be most of them, hire a language consultant to work with you on that language. Sort of standard linguistics, it's really helpful in NLP, particularly when it comes to system evaluation, where you can be like, hey, or analysis evaluation, being like, hey, is this right? Does this analysis look right to you? And budget additional time. So a desire that people have a lot, particularly with chatbots, is to add support for a new language. It's going to take a lot of additional time. Just to know that, prepare yourself for it going into it. It's good to do, but be warned. So those are our 5 key mistakes that I think are pretty easy to make in NLP. Again, I've made these. I know a lot about sociolinguistics, and sometimes I still get like, oh no, I forgot about it. So transcribed speech is not the same as written text. Think about them differently. Expect variation between the ways that people talk and the things that they try to do. Don't do too much text cleaning. Like, try without text cleaning first, and if it doesn't work, then do a little bit, but be lazy with the text cleaning. Look at your metadata. Don't forget about languages other than English. And then a couple minutes, a couple last quick little tips to take with you and tuck in your shirt pocket. Be a little bit paranoid. I think most data scientists are, but don't stop doing that. Look at your language data at every stage with your eyes. And if you don't speak the relevant language, ask your language consultant to look at it. Make sure that, your assumptions about it are correct. Do as little as possible. Try not to do like big transformations that aren't necessary, particularly if you're not using frequency-based techniques. Don't feel like you have to use the frequency-based transformations. Modular flexible pipelines, keep your own components, or any sort of tech process that you're doing, write your functions, make sure that you have a pipeline. Again, general data science advice, but also true for language. Budget for better data, particularly more relevant data. If you can't find anything in your target domain and language, you may need to get it, and it might be expensive. Just know that. Testing, validation, and evaluation. Run your tests, validate your models, evaluate that your system works in practice. Again, just general best practices. And finally, don't reinvent the wheel. Probably someone has already done what you are trying to do with language data. So if you want to make it work, then you can see what other folks have done. And again, the ACL anthology is a really good place to start, or looking at a list of NLP tasks. So that's all I've got. Thanks for joining. I know this was a little bit of a whirlwind, very high level talk. I just want you to think about things, have them in your brain, and when something seems too good to be true, be suspicious. If you have any questions or you want to chat more, I'll be here, or you can at me on Twitter. Thanks so much.
Thank you very much. That was really great. And we are going to continue with NLP in a minute. But first, we are going to do a few more giveaways.